Morning everyone, welcome to this webinar during which we will be discussing various aspects of hybrid and electric vehicles and how they affect technicians and businesses in the aftermarket. First of all, let us introduce ourselves. My name is Tony Gill, I'm the Customer Support Manager here at Autologic.
Good morning all, I'm Damon and I'm an Autologic Technical Support Manager.
Good morning, my name is Steve, I'm a Support Technician and Technical Trainer.
Okay, during the presentation, the chat function is turned on, so you'll be able to ask us any questions that you want to ask. What we're going to do is collate all of the questions over the next couple of days, put together an FAQ sheet with everybody's questions and answers, and then email them out to everybody that's attended the webinar. There'll also be a copy on our website. Included within the questions will be providing some useful links that you'll see throughout the presentation, so you'll be able to look up information for yourselves. So, what we'll be going through today. First of all, we'll just have a quick look at the marketplace as it stands at the moment and how the electric vehicle market is evolving. Be looking at what professional standards are in place in relation to the aftermarket and working on hybrid electric vehicles. Then we'll also look at the risks associated with working on hybrid electric vehicles, what PPE you may need, some basic EV safety, along with some common hybrid electric vehicle problems. And then we'll finish up by looking at what qualifications and training is available and what that means for your business. So first of all, let's look at where the industry is at the moment. So the car park for hybrid and electric vehicles is evolving rapidly. As we can see from this table, out of the 8 million cars sold in 2018, over 100,000 were hybrid electric vehicles, and that was a 27% increase from 2017. We've already seen a 110% increase in battery electric vehicles sold from 2018 to 2019. So there's a lot of evidence showing that although the car park is quite small at the moment, it's growing very, very rapidly. Most of the major manufacturers now having a hybrid electric vehicle in their lineup. So undoubtedly, if you're not seeing hybrid electric vehicles at the moment, you will be soon. There was a survey done or study done last week saying that the attitudes of consumers were changing towards purchasing hybrid and electric vehicles. And if we look at the top 3 selling battery electric vehicles in the UK, you can see why. So, for example, the Renault Zoe, the entry price for this is less than £20,000. So they're becoming more and more affordable as the technology kind of improves and becomes more accessible. Equally, the ranges are extending. So the Hyundai Kona, for example, boasts a usable range of 300 miles. So some of the factors like price and range anxiety that prevented consumers from buying previously are gradually being eroded away, and these cars are becoming more attractive to buy. So what's all the fuss about? Well, electric vehicles, clearly the biggest danger is that they use high voltage. And Steve will be going over some of the risks associated with high voltage in a little while. But clearly, there's a lot of emerging technology around high voltage and so on. There's a lot of things that people may not be familiar about if these cars are in people's workshops. So let's take a look at some things that people should know about working on electric vehicles. And these are some of the professional standards that are currently in place. So the first one you can see is BSEN 50110 Part 1. And this is an ISO standard, so it's an international standard that covers the general requirements for the operation of electrical installations. This is not specific for vehicles, but it covers all electrical installations and basically covers off best practice for working on these installations. And throughout this standard, there's things like how to safely isolate systems, appropriate training for people working on these systems, the environmental and occupational safety, so putting barriers around things so other people can't electrocute themselves and so on. And if anybody's familiar with some of the vehicle manufacturer processes that are in place in dealerships, you'll see that all of these best practices outlined in this ISO standard are closely followed by the vehicle manufacturers. You'll also see these best practices reflected in the Electricity at Work Regulation 1989. And this is a regulation in the UK, again, that outlines what are the best practices and also gives legal guidance for working on any electrical installation. So as it says on the slide there, the regulation will help duty holders meet the requirements of the Electricity at Work Regulation 1989. It will be of interest and practical help to all duty holders, particularly engineers, technicians and their managers. It sets out the regulations and gives technical and legal guidance to them. So the Electricity at Work Regulation is part of the Health and Safety at Work Act. And as laid out in that, the duty holders are employers, employees, and the self-employed, and in some cases even trainees. So everybody has a responsibility to adhere to these regulations. And within this regulation, there is a part here where it specifically relates to vehicles. So at the quote at the bottom there, the regulations may apply to electrical equipment on vehicles if this equipment may give rise to danger. And as we've already said, there is a possibility of danger when working on the high voltages associated on these vehicles. So the last piece here is around the Health and Safety Executive. So the Health and Safety Executive, obviously, they are the body that's in place in the UK to ensure that people are adhering to the regulations as laid out in the Electricity at Work Regulation. So they're the people, obviously, that will come and investigate if you have an accident or there's something's gone wrong with at work. And they do have some specific guidance in relation to working on hybrid and electric vehicles. Throughout their guidance, there are numerous references to following the manufacturer's instructions for working on hybrid and electric vehicles. So clearly there will be a requirement for the aftermarket to access the OE information for making the vehicle safe and carrying out repair. It is particularly important that to familiarise yourself with the manufacturer's instructions, because you may find that for some models of cars, for instance, you may have the same model that's available as a battery electric vehicle, but it's also available as a hybrid electric vehicle or a plug-in hybrid, and the process for making each of those vehicles safe may be different. So it's very, very important that the manufacturer's instructions are always checked. The other thing that's stated within the Health and Safety Executive's advice is that people working on hybrid electric vehicles should have the appropriate qualifications. And the quote there from the page on their website is a specific training with qualifications awarded by organisations such as the IMI Awards is available. So it's very, very important that the appropriate training is carried out, and Damon will be talking about training towards the end of the webinar. So I've just mentioned the IMI, and it is the IMI that's leading efforts to secure minimum training standards for technicians working at different levels on hybrid and electric vehicles. As already said, there are the processes and so on are very much in place in the franchise dealer network, because obviously they have a duty of care. They're the people writing the processes for replacing parts and working on vehicles. So they've put very stringent processes in place. So there is adherence to the electricity at work regulations and so on. But none of these processes need to be followed in the aftermarket. So it's the IMI is kind of leading the charge to say, well, okay, in the aftermarket, what is the minimum standard? What does everybody need to do? Because that's not in place at the moment. The IMI have set up the Electrical Vehicle Advisory Board, which takes a cross-section of people working in the aftermarket, and they're looking at the main factors that need to be considered when working for putting in professional standards for working on electric vehicles. And a recent poll of IMI members showed that 98% of responders think that regulation of technicians for working on electric vehicles is a good idea. And raising professional standards is a key area of the IMI's campaigns for change. And there's a Twitter feed that you can join the conversation at IMI TechSafe to have your say. The IMI also mentioned in the government's Road to Zero paper, and the quote there from that is, we are reviewing whether current regulations are sufficient to protect mechanics working on electric and hybrid vehicles. We are working with the IMI to ensure the UK's workforce of mechanics are well trained and have the skills they need to safely repair these vehicles safely. So the Road to Zero paper was the government's pledge to ensure that, or to see that 50% of vehicles, new vehicles sold by 2030 are low emission vehicles. So as with anything governments do, this may take some time to see any legislation come into place to enforce these standards. So I think going back to the Regulation at Work Act, if you see, it's the duty holders' responsibility to make sure that some precautions are put in place to make sure people are safe in the workplace. It's also worth considering things like insurances and so on, that if you've got people working in your businesses that aren't trained, and if there was an accident, does your insurance cover that? Is your insurance aware that you're working on electric vehicles and so on? But ultimately, it's all of your responsibility to make sure that you're putting some precaution in place and making sure that people are sufficiently trained. So I'm going to hand you over to Steve now, who's going to take you through some basic EV safety and take a look at some common faults and so on. Steve.
Thank you, Tony. Right, good morning, everyone. So, due to the increase in HEV sales, the probability of our customers coming into contact with these vehicles is going to increase dramatically between now and over the next few years. These vehicles can be worked on safely, but as Tony pointed out, correct precautions and manufacturer safety instructions need to be used. A lot of new components in these vehicles, such as inverters, battery technology, motor cooling, few of which exist in our current vehicles. So the need for training is very important. So what does the garage require? We require, or you guys are going to require, staff training, potentially new tooling to be purchased, an understanding of safety and the importance of being safe. Knowledge of new technology, as I just said, not seen on conventional vehicles. So a few myths and frequently asked questions. Will an HEV just run off the battery if it's got no fuel in it? If you try and run a hybrid purely on the electric engine without having the fuel to power it, it will result in damage. Will the HEV Will the high voltage system shut down in an accident? Yes, it will. Maybe, maybe not. It depends on the severity of the accident. Again, I would always assume that the vehicle would be still powered up when you get to the accident until you confirm it otherwise. Can an HEV be bump started? No, it cannot. Can these vehicles be towed? No, they cannot be towed because you can generate electricity into the motors, and then you've got the potential again for electrocution. Can I take an HEV through a car wash? Yeah, it's just the same as a normal vehicle. Go through a car wash, there'll be no issues with getting electrocuted. Do hybrid vehicles need to be plugged in overnight? Some can be plugged in at night into a power source if you want to warm the vehicle up, or if you want to demist it to save on the battery. Not all need to be plugged in. Last one, do these vehicles require special maintenance? A technician should be able to service a hybrid as they would any other vehicle. It should be a reduced maintenance cost because the engine shuts down when the electric motor is taken over at idle speed. So, back onto risks. High voltage components and cabling are capable of delivering a fatal electric shock. You'll see later the fire risks and the explosions that potentially can happen. Lack of workshop skill set. Quite a few people in the aftermarket are trained, but there is a lot of people out there who still haven't got any training or any idea of the risks. Manual handling, again, a lot of these components are very heavy, so care must be taken when removing them or taking them out of the vehicle. Potential for release of explosive, harmful gases or liquids. Just bear with me 1 second. Just bear with me 1 second, apologies. Right, okay. Sorry about that, a bit of a computer issue. Okay, so, and finally on here, possibility of people being unaware of vehicles moving, as when it's on electric power, they're silent in operation. Okay, so basic EV safety, we're still on this. Difference between workshop safety and vehicle safety. So workshop safety, we need to make the environment safe for the technician to work on the vehicle, make sure there's it's dry, it's a clean environment. And then again, we need vehicle safety to make sure that the vehicle is safe for the technician to work on. As it says there, generic risk assessment, floor slips, general practices, and general health and safety. Also, as a workshop owner, you should be providing your staff with specific assessment sheets for vehicle safety, a checklist that should be kept on file, staff training at the required level, and obviously correct and current HEV PPE safety equipment. So, as regards yourselves and working on them, all technicians working on these vehicles must be physically fit. You should not work on these vehicles if you have a pacemaker, an insulin pump, or any heart issues. As it says there, DC voltage causes muscular contractions. Basically, if you grab hold of something, you will start to burn from the inside out, and the supply or the component will not let you off the vehicle. So it would be down to another person to pull you off the vehicle should, in the unlikely event of an electric shock take place. And again, it says all high voltage components must have a warning label, and all high voltage cables will have orange insulation. So, should a person get involved in a high voltage accident, quickly assess the situation and call the emergency services, or if you're involved in rescuing the casualty, get someone else to call. Do not touch the injured party until the power source is isolated or the casualty has been moved away from danger. You'll see it in a short while, I'll show it to you, but there's an approved rescue rod to move the casualty from the safe area so you don't get electrocuted yourself. Apply CPR medical assistance, and if possible, power the vehicle down so you or others don't become a casualty. When the emergency services arrive, inform them the vehicle is a hybrid electric vehicle and the casualty has been electrocuted. With all the safety features that manufacturers have built into these vehicles, it's very unlikely that you're going to get an electric shock or any kind of issue, but it's best to be prepared. So page 19, workplace PPE. So what do we need? So for the next 2 pages, you'll see the PPE that you will require to work on these vehicles. So let's have a scoot round these. So overalls, they're to assist in fire prevention. You've got non-conductive safety footwear. So most workshop boots are anti-static, which means they will earth the wearer. If you're exposed to high voltage, the electricity will earth through your body and feet if you were not insulated from the ground. Next one there, class 0 gloves rated to a minimum of 1000 volts. And then we've got some signage to warn other people or possibly customers if they're in your workshop that you're working on HEV and to keep away. Again, the cones and the barrier kit you put around the vehicle, and that would stop anyone approaching the car. The rescue rod I discussed a couple of minutes ago, that is basically to grab the casualty and to pull them away from danger. Cat 3 multimeter, that will measure and withhold 1000 volts. Obviously, you'll need that to check for your absence of voltages once your high voltage service plug is removed. You've got some safety mat in there. You can stand on that or you can cover your high voltage components with it. Some of these vehicles, there's a padlock that you can put over the safety lock, and that will prevent it being reinstated and high voltage coming back on board. Got high voltage tools and a protective mask. And then as it says at the bottom, finally, just make sure that you've got a trained first aider on site while you're carrying out these repairs. So these are basic prerequisites. It's sort of like manufacturer-wide, shall we say. However, if you're going to work on these vehicles, always get the manufacturer's instructions. So first of all, make sure the car is correctly switched off. So make sure the stop-start light isn't on and the ready light is off. Move the key away from the vehicle. Industry standard says it's 3 meters. Make sure your ramp legs, your jacks, or your axle stands are correctly positioned and you're not going to puncture the battery or any of the high voltage cables. Make sure the vehicle's parked on dry flat ground before you start any work. Check all special tooling's available, it's not broken and there's no damage. And then consider also any previous repairs that have been carried out. Possibly speaking to the customer, has it been in a body shop, has it been in another garage being repaired? And again, if you're not working on the vehicle, ensure the person who is has the correct qualifications. So this is an example of a high voltage component, a high voltage aircon compressor. Cools the cabin obviously, but on some vehicles it can also cool the high voltage battery. It's electrically driven, and to remove the component you would have to be level 3 IMI accredited. On these vehicles they use different oil, they use POE oil, not PAG oil. If you put PAG oil in the circuit it will become conductive. So the next few slides are some cases that are coming to the technical teams here at Autologic. Every one of these cases, all the guys are trained to level 3 IMI, and obviously we can give them their support. So I'm just going to run through these now quickly with you. So this one is 2015 fully electric Kangoo van. The issue was it intermittently does not charge correctly or does not charge at all. So work carried out by the technician, they've confirmed the fault, they've plugged it into their own on charge point. No issues there. Scan the vehicle using the diagnostic tool, no fault codes, and then they've called into us for some assistance. So we viewed the scan and confirmed no fault codes in any of the control units across the car. As the other charge points have been used and it still didn't charge, the support technician has then ruled that out. He's also ruled out the charging cable as another cable has been used. As it says there, after ensuring that the technician's got all the relevant safety equipment, using the Rescue Lens app that we use here, we have spoken to the technician and we've advised him to power the vehicle down. and check the charge connector pins, as this is a known incident. Technician at the workshop located a cracked pin causing this issue. We've then advised on replacement of the charge connector and assisted the technician in rearming the high voltage system. Case study 2, 2014 i3. This is an electric vehicle with a small motor in the back, what they call a range extender. And the issue on this was a fuel flap operation. So technician has confirmed the fault, he's manually opened the flap, and he's confirmed the motor operation by using the activation on the tool. He's then called us, we viewed the scan, again confirmed no faults. We have asked the technician to check the in-tank pressure sensor on the live data, which appeared correct. We've then asked the technician to run the activation of the motor and confirm its correct operation. As it says there, again using the Rescue Lens app, we've advised the customer to power the vehicle down using our help, and we've advised him to update the software in the TFM control unit, as this is a known issue. To actually update this, it is a must to power this vehicle down, so that it does say in the documentation to power the vehicle down to do this. Finally, 2015 Golf e-tron. Customer complaint is the alternator warning lights coming on. Can lead to discharge of the 12-volt battery. Technician at the workplace has done a vehicle scan. He's found a fault code for DC-DC converter. He hasn't done any work because he wasn't sure on the fault code, so he's given us a call. We've spoken to the technician and we've advised him it's a known issue, and we have asked him to check the production date on the DC-DC converter. We've confirmed that there is a modified part, so we've assisted the customer to power the vehicle down, and then we've assisted him in replacing the component and reinstating the high voltage system. So hopefully on the right hand side you can see this vehicle. What happens is smoke starts coming out from under it, and then there's a massive explosion. So this was on April the 22nd this year. The team from Tesla are going out. They're going to have a look at the vehicle and try and work out what's happened to it. They think it's some issue with the battery, but again, until the people actually get out and look at it, they're not really sure. Something to be aware of if you've got vehicles parked and they're EV or high voltage, maybe park them outside. Apparently burnt down quite a lot of the car park, and there was quite a lot of damage to other vehicles. Okay, so we're just going to go on to another couple of bits now. Regenerative braking. We're going to just brush over this, but if you do come on the courses, we'll go into this and all the other points more in depth. So energy recovery slows the vehicle by capturing and converting kinetic energy into a form which can be immediately used or stored back into the high voltage battery. It will improve overall efficiency to the vehicle, and it will also extend the life of braking components as they're not going to wear out. Again, as well as being stored in the battery, some of the energy can be stored in the inverter to assist in acceleration. Right, so lastly, just a quick bit on charging. This is currently the three main HEV charger types. So slow charging, up to 3 kilowatts, 6 to 8 hours to charge overnight. Fast chargers, 7 to 22 kilowatts. This can fully recharge in about 3 to 4 hours. And then we've got the rapid chargers out there. It's quite a lot of these starting to come on board now. 43 to 50 kilowatts. They're able to provide an 80% charge in around 30 minutes. With the battery technology moving forward as it is, in a few years' time, these cars are going to be able to do what we would consider to be a nominal mileage. So there's not going to be any of what Tony referred to earlier as range anxiety. That's the final slide for myself. As I'm part of the team delivering hybrid training, I look forward to hopefully seeing you, some of you in the future on future training courses. And I'll pass you back to Tony now. Thank you. I beg your pardon, we're going on to Damon first of all, and then on to Tony.
Good morning all. So a couple of things I want to go through this morning. Obviously some of the bits that Tony and Steve have already touched on, but to go through obviously in the next few minutes why training is essential when working around high voltage systems. So firstly, all employers have a duty of care and legal responsibility to all of their staff for taking the correct precautions and preventative measures to make sure their employees are safe. I'm sure most of you out there are employers, so maybe obviously you need to look into making sure everyone's got the relative training courses. The UK government have set a target of more than 50% of all new vehicles in the UK to be electric by 2030. And considering the current issues we're seeing with the fossil fuels, we may well find that vehicle manufacturers will make this happen sooner than 2030. So with the current projected growth of high voltage vehicle sales in the UK and worldwide, it's inevitable that these will be coming out of the dealer network and they'll be coming to you for all repair and maintenance. So what we've recognised over the last year or so is the shortage of high voltage trained technicians. We've seen an increase in technical support requests, but we haven't seen an increase in those trained to work on them. So there's only 5% of trained technicians with electric and hybrid vehicle qualifications. So because of the trend we're seeing with our customers servicing and repairing high voltage vehicles, this trend has led us to review the way in which we support our technicians working on these vehicles. As Steve said earlier, we've now introduced Rescue Lens, which we're using to talk people through the repair and diagnosis of electric vehicles. Because if not treated with the right duty of care, they can cause life-changing injuries. So because of this, we're now offering all our Autologic customers a subsidised IMI certified electric vehicle course. We're running this in conjunction with the RMI, and we're aiming to bridge a skills gap when it comes to working on high voltage vehicles. So what I'm going to do now is going to run through the 4 levels of electric vehicle certification. And obviously you can see where this fits into your business and your staff. So level 1, this is a high voltage awareness course. This is aimed more at your front of house staff and the less hands-on staff. Because again, they still need to be aware on who's safe to work on a vehicle and what level is needed to work on each part of this vehicle. Then after that, this is the first one that is at level 2. This is the first one that actually gets you working on the vehicle itself. And this is the hybrid and electric vehicle repair and maintenance. So this is the minimum you need to be able to physically make the car safe. So once you've made the car safe, then with a level 2, you can then work on the non-high voltage systems. Following on from that, we'll be going to level 3, which is electric and hybrid vehicle repair and maintenance. So this gives the technician the ability of making the vehicle safe to work on, then also to replace any high voltage components. So as Steve touched on earlier, things along the lines of air conditioning compressors and our high voltage components, various heating system components. And then after that, we've got level 4. So this is the highest IMI accredited level for hybrid training. And this is test and repair of electric vehicle and components. So this is aimed for all of you looking at working on live high voltage vehicles. So this is such as diagnosing things like battery issues, charging issues, etc. Now another thing just to remember, and this is something that we've seen quite a lot on recently, is please remember when you're attending a training course, you can attend a training course and you can be given the information you require, but it's maybe not the same as an accredited training course that's recognised by most major automotive bodies. So I think from the last 4 levels I've been through, please think about your staff and your business and what they need to be safe in the future. Now, if anyone's interested in attending one of our training courses, we currently offer a level 2 hybrid course, an IMI certified. We're offering this in conjunction with the RMI. To see a full list of these, please go onto our website. That's autologic.com/training. And we are lucky enough that we can now release a level 3 course. So these dates will be released in the next week or so. If you'd like to register your interest, please go to, again, autologic.com/training and register your interest, and dates will become available in the next week. Lastly, the last thing I want to touch on is how we support our hybrid customers in the workshop. So there's what we've got. We've run a new process. So this process is, once you've gained an IMI certified qualification, then you need to send in a copy of your certificate, and we'll also need a copy of photo ID, so driving license or passport. After this, once your information has been approved, so we've verified your certified training and your ID, then you've got access to our technical support service. And as I said earlier, what we're using for our technical support service, we're also using rescue lanes to make sure that the vehicle has been made safe for you to work on before we continue. Any questions, obviously the chat function is switched on, please do send them in and we'll hopefully answer your questions shortly. Thank you very much. I'm going to pass you over to Tony, who's going to run through some of Autologic's other processes and systems.
Okay, thanks, Damon. Well, I hope everybody's found that useful and interesting. I'm just going to finish off by just a little bit of who we are. So Autologic provide a range of diagnostic solutions into the aftermarket. So we provide a diagnostic tool. We also provide a support service for technicians for diagnostic help on cars. As well as that, we also sell picoscope, battery support units and cardiac pass-through VCIs. We'll be collating all of your questions and sending them all out to everybody that's attended today. Also, they'll be available under the news section on our website. And as I say, along with that, we'll put all the links and the case studies and so on will all be in that documentation. Thanks very much again for joining us. Goodbye.